Hello, welcome to the video lesson for ratio tables 612A. We will be learning about what ratio tables are in this part of this unit. A ratio table, the definition is, it is a table that has pairs of corresponding values with an equivalent ratio between each pair. So let me show you an example of that. So here is a ratio table. It has pairs. So remember that a ratio is comparing two quantities. Here's the ratio 1 to 4. The top row will be one of the quantities. The bottom row will be the other quantity that we're comparing. And these pairs will have an equivalent ratio between each pair. So let me go a little bit further into that. If you notice that 1 to 4 and 2 to 8, 2/8 and 1/4 are equivalent, so is 3/12 or 4 out of 16. They're all 1 to 4. You might also notice that this is counting up by 1, so for every 1 that's added to the top, there's 4 added to the bottom. So that's one key thing to pay attention to with ratio tables. So let's go to the quiz. I think the quiz has some great examples in it for ratio tables. You can get there through the home page. Click on Ratio Quiz 2 if you haven't done it. Or if this was just confusing to you when we did it in class, you can watch this video as many times as you'd like. Let's see. So a ratio is relationship between letters and numbers. No. The difference between two quantities, that would be subtraction. A way to add fractions, that would just be adding fractions. Comparison between two quantities, that we need to know that a ratio is a comparison between two quantities. The table just holds that information. Okay, so this one, first one says, fill in the missing value on the ratio table that represents the ratio 1 to 4. Similar to that example that we just saw, what was the missing value on that ratio table? Well, this one's counting by 1s, this one's counting by 4s. What is missing between 8 and 16 on that table? Number 12 is missing. So 12 would be the missing value. Now we have a table that doesn't have anything filled out on it. So how do you set this table up? And tables don't always have to be horizontal. They can actually be vertical tables. You can do them this way as well. So I'll do one vertical just to show you that it's the same thing. We have red to green. So the first quantity and the second quantity. And the problem says in a bag of M&Ms, you find that for every 3 red M&Ms, there are 4 green M&Ms. What is the ratio of red to green M&Ms? Okay. Well, if there were, we'll just do a couple. 3 for every 4 green. So if there were 4 green, there would be 3 reds. If there were twice as many greens, 8, there would be twice as many reds, 6. If there were 3 times as many greens, there would be 3 times as many reds. If there were 4, there would be 4 times as many reds. So that is a complete ratio table. Well, not complete. It could go on forever, actually, but for 4 values, it is completed. The one that we want to know is the most simple version. So you would write it in simplest form, which is 3 to 4. 3 and 4 cannot be simplified because it doesn't have a common factor between the two numbers, where 6 and 8 do have a common factor. A common factor means a number that you can divide both of these numbers by and get whole numbers as a result. So you could divide 6 by 2, and you could divide 8 by 2 by the same number, and you would get 3 and 4. So this is the simplified version of 6 to 8. They're equivalent ratios, though. This table has equivalent ratios between each pair. Okay. See if I can find one that is kind of tricky here. Okay, this last one. Let's see if the ratio table can help figure out what this would be. And I'm going to take a little bit of a shortcut to get there, but it's saying if on average you answer 4 out of 5 questions correctly, how many questions would you expect to answer correctly if there were 100? So what are we comparing? We're comparing two things, but what two things are we comparing? First one would be the 4, which is how many questions you answered correctly. So answered correctly. The second quantity is the total number of questions, I guess, out of how many. Okay? So we know that out of 5, you answered 4 correctly. The question wants to know is way over here, if there were 100 questions, how many would you expect to get correct? Following the same ratio, that if for every 5 questions you answered 4 correctly, if there were 100, how many would you expect to get right? Well, this would be a lot of numbers to fill in. To get all the way up to 100, you could get there, 5, 10, 15, 20. So this would be 4, 8, 12, 16, and you could keep counting up. But there is a quick way to get there, which is using multiplication. Just like I don't need to know 10. I could go right to 20 by saying 5 times what is 20? 5 times 4 is 20. So I could get this value by saying 4 times 4 is 16, and I could skip right to this one. Once I'm here, I can get to 100 pretty easily. You don't have to go this route. You could go straight from 5 to 100, or from 5 to 10 to 100, or from 5 to 50 to 100, or 5 to 25. There's a lot of combinations to get there. You'll still get the same answer. But if you go 20 to 100, how many 20s are in 100? There are 5 20s. 5 $20 bills would be $100. So 16 times that same factor of 5 will keep it proportional. That if one's going to be multiplied by 5, the other one's multiplied by 5, and it's proportional. So 16 times 5, I would do 5 times 10 to get 50, plus 5 times 6, which is 30. So 50 and 30 gives me 80. So that is the answer. 80 out of 100 would be what you would expect to get if you got 4 out of 5 questions correct and there were 100 questions. Or another way to look at this is percent. Percent means per 100. So 80%, 80 out of 100 would be 4 out of 5. One thing to keep in mind on this is that sometimes we're working backwards to try to figure out other parts of the table where we're not starting with the original ratio, we're starting with a unsimplified ratio, like in this example here. So it says 3 to 24. Well, 3 to 24, I'll just try to keep the box part. So this is not questions anymore. We have blocks to weight. So the two things you're comparing are the number of blocks to the weight in pounds. Okay, so looks like 3 blocks weighs 24 pounds. What is it asking for? How much would 12 blocks weigh? Okay, well, if 3 blocks weigh 24, one strategy would be to figure out how much 1 block weighs. And that would help you figure out what 12 blocks weigh. Or if you were using the same strategy that we covered in the last example, you can multiply up to find the 12. So what do we want to know is, we want to know this number, how much 12 blocks weigh, or how much 1 block weighs. So if 3 blocks weigh 24 pounds, then 1 block weighs what? So the way to find, this is actually coming up in the next unit, but I'll get into that, is unit rate. What we want to know is, it'd be nice to know the weight per block is what we want to know. And to find that, you take the weight of what you do know. One relationship here is 24. Per means basically divided by, or it's a ratio. So like 1 per something, or 3 blocks per 24 pounds, 24 pounds per 3 blocks. So we want to know weight per block, so we're going to do weight divided by the number of blocks, which gives you the unit rate. This is called a unit rate. It's the weight per block, 8 pounds. So we know 1 weighs 8, so 12 must be 12 eighths. Or if we're going from 3 to 12, if we know how much 3 blocks weigh, then 12 blocks must be 4 times as much. So the weight must be 4 times as much. 4 times 24, 4 times 25 is 100. So I'll take away a group of 4, we'll get 96. 96 pounds would be the weight of 12 blocks. All right, if you need any more practice with this, let me know. I have tons of ratio tables that we could do. And each part of this unit is going to build on this idea. So we're going to bring in unit rate next, and then start looking at tables, and then looking at proportional relationships. There are some great videos of how to figure out equivalent ratios too that I could share. Just let me know if you have any other questions.